Hello everyone and welcome to another video where today, occasionally I browse through the YouTube shorts just to find fluff fun, right? Flatzoid posts things there, and I've also seen bits and pieces of other flat earthers there. But usually they're not worth reacting too much. Sometimes they link a video in the comments and then I will have a look at that. But sometimes I find like shorts from other things that are not flat earthers that kind of bother me, and this one bothers me a lot. And I will show you why. Let's have a look at the short first.
Scientists have just found signs of life and intelligence on a planet outside our solar system.
Now, that already bothers me. First of all, signs is a bit unclear. If you mean evidence, then all right, I will let that go through, even though I don't think it's solid enough for evidence. But what bothers me is life and intelligence, because how would you, no. Life, possibly, sure, there are biomarkers that you can use to identify life, but I have an issue with intelligence. How would you show intelligence, right? So already, but by the way that this is structured, this is very much an appeal to sensationalism. And if you know, if I think I made a video about it, I hate sensationalism deeply.
The planet is called K218b. So
the thing about K218b was that they made an observation with the James Webb Space Telescope there. They recorded the spectrum of the atmosphere when the planet was passing in front of its star. And they found some interesting things there, like dimethyl sulfide, I think it was, and other compounds that are usually on Earth only found from life, right? From algae, I believe, or something like that. And if you find things like that in the atmosphere of a planet, it is I don't want to say sure, but a solid indication that there might exist life on this planet, right? But the way it is depicted here is that it is completely that's a proof, kind of a safe and sound discovery that's already kind of finished, but it's not. It's so much not.
And it's about 2.6 times the size of Earth. And
it's a mini Neptune. So you have so it has a thicker atmosphere than Earth, right? And it's kind of like a hybrid, if you will, between a gas giant and a rock planet. But more about that in just a bit.
Orbits a red dwarf star about 124 light years away from us. But what makes this planet so special is that it has water and
we think it has water.
A hydrogen-rich atmosphere.
Hydrogen-rich atmosphere is not special. All the gas giants have a hydrogen-rich atmosphere, and a lot of other exoplanets that we know of now have a hydrogen-rich atmosphere. So that's not impressive, and hydrogen on its own even isn't good for life. So why talk about it in this context?
Which could support life, and not...
Again, hydrogen is kind of bad at supporting life.
Just any life, but possibly complex and diverse life forms that could rival those on Earth.
Pure speculation and sensationalism.
How do we know that? Well, thanks to the James Webb Space Telescope that has detected carbon-bearing molecules such as methane and carbon dioxide.
I love how they completely go away from the point. Both carbon dioxide and methane can arise from non-life. That's not the important ones. You shouldn't be focusing on those. These are really not important for that. There are Titan, the moon, Titan, has both of these present, and we don't look for life there.
Are produced by biological processes on Earth, and possibly dimethyl sulfide.
Now they're getting places. Dimethyl sulfide, and I will talk about this in a bit. We believe we've found traces of dimethyl sulfide,
which is only produced by life on Earth. But that's not all. Webb also found nitrogen dioxide and chlorofluorocarbons, which are...
Yes, they found both of these, but again, there's a bit more to it than just saying we found them.
produced by human activities on Earth. These are called technosignatures, and they indicate the presence or activity of intelligent civilizations on a planet. This is a groundbreaking discovery.
Not necessarily.
That could change our understanding of ourselves and our place in the universe. If you want to learn more about this amazing story, check out the full video on YouTube.
Yeah, we won't. So what I'd like to do instead is have a look at the actual paper, right? This is the paper. It was accepted in October of 2023. I'm recording this in April of 2024, so we have a bit of hindsight power now. And I would like to say that even in the paper itself, I would encourage you to read it. It's a solidly enough read. And here you have the transmission spectrum, right? We find a lot of methane at the couple of micron wavelengths, and then we find it around between 3 and 4. They find dimethyl sulfide. Although they say themselves that they are not exactly sure about the dimethyl sulfide. The issue is that you can fit a whole suite of molecules to dimethyl sulfide, right? And what they find here for no offset is around, I can't explain what the offset is right here because it's not exactly important, but they're not exactly that sure about the dimethyl sulfide. 2.4 sigma is difficult position to have. It's right at the area where I would say, oh, this could be something, but I wouldn't call it sure. The sigma intervals are how statistically significant your results were, right? So if you have, for example, in medicine, you're required to have somewhere between 4 and 6 sigma, depending on what you're doing. Particle physicists like to have 4 or 5 sigma or something like that, right? The thing that I'm doing right now, because I'm still in the United Kingdom, the thing that we are doing right now here, we have very solid data where we have some that are above 5 sigma, so they are, for our purposes, extremely secure, but we also have some that are just like around 2 sigma, or 2.5 sigma, just like this one, where we say we still report them, but we also say, this data isn't exactly secure here, right? And the issue is that this is right in the point where you are somewhere in between. Yeah, it's probably there, and it looks like it, but we're not sure, right? And that's right in between of where that is. They even said it. Notable constraints on 2-methyl group, blah, 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 terrestrial biomarkers, where they say that, they predicted to be detectable here, in this K218b. They get a mixing ratio of blah, 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 blah. And when they talk about the significance, right, they actually spend quite a lot of time talking about the details. We infer DMS at 2.4 sigma confidence for the no offset case, but only 1 sigma for the 1 offset case and no significance for the 2 offset case. Nevertheless, it's shown in figure blah that all 3 cases all 3 cases, the retrieved posterior distribution of DMS shows notable peaks within 1 dex of each other, blah, blah, blah. Essentially what they're trying to say here is that they aren't exactly sure. They find methane and CO2 to be very confident. They were around 3 or above 3 sigma, so those are kind of there. And by the DMS, they're like, they themselves are not confident enough to say that it's there. And that should really, that should be an indication that you can't say, we've just found signs of life and intelligent. I mean, what the fuck, guys? Sorry for swearing, but guys, come on, that's not what we're doing. And I love how the video here, according to the comments, right? It came out like a couple of months ago. 6 months is the oldest comment that I found so far, right? And so this video came out right when the paper came out, which is again a bit of sensationalism, because usually you want to give people some time to react to what they're just what the paper says, right? Because you could be wrong. you can't just publish such a video without giving the scientific community time to examine what they found there, right? Which is a bit, but okay. And they go on to say that is indeed confirmed by future observations to be greater than blah. The result would require very, very high biological production rates. So they say if it can be confirmed, probably life is there, right? But they say themselves that it's not clear enough just yet. And that's the original paper. So the original paper is highly skeptical of their own results. They say that they report it to be 2.4 sigma, which is perfectly fine. But then they say we need follow-up observations to confirm or to deny this, what we found. And the thing that has crystallized since, as far as I'm aware, this is not my area of research. I want to make that clear. I'm not an exoplanet guy. I did the courses at university for exoplanets, and I did a seminar or 2 seminars even that revolves around exoplanets and habitability thereof, right? But it's not my active area of what I'm doing. And what has crystallized, what I found since, is that, well, the observations can be explained by gas-rich mini-Neptune with no habitable surface, where they go into detail specifically about the DMS. They weak evidence, right? Because that it's kind of exclusively produced by life on Earth. So if you would find it, the only place that we would know where it came from would be life, right? And so they say that they only found weak evidence. Yeah. So they explain here how the spectrum that I showed that was also shown in the video, the spectrum here can be explained by a whole slew of other molecules more or less accurately, going into the reaction and thermodynamics of it. Essentially what this paper did is they made a simulation of how they would behave, of how the molecules would behave photochemically, and they point out how it would work the best with a mini Neptune that has a hydrogen-rich atmosphere but actually no surface. It would yield very similar results to what they assumed with a kind of planet that has a surface and a different atmosphere. So really, what I'm trying to say here is, with this video, it's a bit of a ramble, I know, and a rant, but what I want to make clear with this video is that you need to be aware of this kind of sensationalism. It really doesn't lead anywhere. I don't get why you would do it. If you say, oh, we have just discovered life, this would be one of the hugest discoveries in the history of mankind, right? And that's just not what happens. You should say, we have found some signatures that could possibly explain with life being present on this, but we need to do follow-up observations and this and that and what the problem is, because I think that way you can get people more interested in the topic, actually. So, yeah. Sorry for the rant, guys. But with that, I think I will leave it there. And I thank you very much for watching. If you enjoyed this video, maybe leave a like. If you didn't enjoy it, leave a dislike. If you enjoyed a lot, maybe considering subscribing. Yeah. So that was that. I will see you in the next video. Until then, have a nice time. Goodbye.